This is conservation of momentum. It's an example that I asked you to put in your notebook on page 11R. And this is the fall of 2012. Let me read the problem, and what you need to do is you need to pause this right now, and you need to write the question down. And then when you unpause it, you can go on and we'll talk about how to solve the problem. So go ahead and pause it now, and then unpause it when you finish writing. Miko, mass 39 kilogram, is riding a skateboard, mass 2.3 kilogram, traveling at 1.6 meter per second. Miko jumps off and the skateboard stops dead in its tracks. In what direction and with what velocity did she jump? Okay, so you read the problem one time, and then we are going to go back and we're going to reread the entire problem, and we're going to stop every time we think we've come to a variable that we need to write down. So I'm going to write my givens, and then I'm going to begin reading. Miko, mass 39 kilogram. So Miko has a mass of 39 kilograms, so I'm going to write M, and then I'm going to put a subscript M for Miko. And then that equals 39 kilogram. Is riding a skateboard, mass 2.30 kilogram. So I'm going to write mass skateboard, subscript S, equals 2.30 kilogram. Then I'm going to keep reading. Traveling at 1.6 meter per second. Okay, let's think about this. The skateboard is traveling at 1.6 meter per second. In all likelihood, Miko is, since she is on the skateboard, she's also traveling at 1.6 meter per second. So I'm going to write V Miko initial equals 1.6 meter per second. And the skateboard initial is also 1.6. I didn't put the 0. I'm going to go ahead and put it here. Meter per second. Then it says the skateboard stops dead in its tracks. Miko jumps off and the skateboard stops dead in its tracks. That means the final velocity of the skateboard is 0 meter per second. It doesn't say anything about the final velocity of Miko. And in fact, in the next sentence, it says, in what direction and with what velocity did she jump? So the unknown is the next part of our guess method, and the unknown we're looking for is the Miko final. Make sure you put the question mark. Now there might be other things we need to solve for in some of these problems, but we want to write down only what we're looking for in the unknown. Now it says in what direction and with what velocity did she jump. Hopefully you see that the direction is the sign of the velocity, and what they refer to as the velocity is really the magnitude of the velocity, the strength. So they want the sign and the strength of the velocity. Okay? So let's write down our equation. We're talking about the conservation of momentum. So we know that rho Miko initial plus rho skateboard initial equals rho Miko final plus rho skateboard final. Now I'm going to break this down for you, and you can do this if you would like to, and you can write this equation, which is the same thing but broken down. We have the mass of Miko times the velocity of Miko initially plus the mass of the skateboard times the velocity of the skateboard initially equals the mass of Miko times the velocity of Miko finally plus the mass of the skateboard times the velocity of the skateboard finally. Okay. Now, we're going to write down our substitution. At this point, if you are good at manipulating equations with variables, manipulate this equation so that you end up with the velocity of MECO finally on one side of the equal sign and every other variable on the other side of the equal sign. That's going to take you moving this factor over here and dividing the whole thing by the mass of MECO. If you are not good at that, then plug in the values first, then do the manipulation. So we have the mass of MECO, 39 kilogram, times the velocity of MECO initially, which is 1.6 meter per second, plus the mass of the skateboard, which is 2.3 kilogram, times the velocity of the skateboard initially, which is 1.6 meter per second, equals the mass of MECO, which is 39 kilogram, times the velocity of MECO finally, which is what we're looking for, VMF, plus, now I'm going to have to write this below because I've run out of room on this line, the mass of the skateboard, which is going to be 2.3 kilogram, times the velocity of the skateboard finally, which is 0 meter per second. Okay, so that's my whole statement. We're going to have to work it out, and this is going to be more than one step in our substitution phase. So first of all, I have 39 times 1.6 gives me 62.4 kilogram meter per second, plus 2.3 times 1.6 is 3.68 kilogram meter per second, equals 39 kilogram times the velocity of MECO finally. Okay, I'm kind of messed up here. I'm going to put like a little divider thing here. I should have skipped another space, but I'm not going to go back and re-record this. So I've got 39 kilogram times VMF. Now this notation is just because I ran out of room, okay? So don't be confused by this. This is 39 times VMF. See right here. Okay. Now these are the same units, kilogram meter per second and kilogram meter per second. So I can add these two values together. Okay? And so we have 62.4 plus 3.68 gives me 66.08 kilogram meter per second. Okay? And that is equal to this value here, 39 kilogram VMF. Okay? This is, remember, this is part of this here. Okay, how do I get VMF by itself? Well, divide both sides by 39. And I get my solution, which is going to be VMF equals, see this cancels, 39 divided by 39 is 1, so it is equal to 66.08 divided by 39, and that gives me 1.694. Now I'm going to round this to, I'm going to use significant digits. I've got 4 significant digits, and so I'm going to say it is 1.694. You know what? It's actually 3 significant digits. So I'm going to say 1.69 meters per second. If you notice the units, kilograms times meter per second divided by kilograms gives you meters per second. Okay. That's my answer. Okay, what I'd like you to do